Hello guys, welcome to today's lesson, and today we are looking at linear equation and inequalities. Before we delve deep into it, I want us to understand certain key terms anytime we are talking about linear equations and inequalities. We will be looking at what a term means. Now, according to the definition of a term in linear equation, we are referring to a constant, a variable, or a product of a number and a variable. A term refers to a constant, a variable, or a product of a number and a variable. Now, when we talk about a constant, what does it mean? We are talking about values that do not change anytime we are solving equation. And when we talk about variables, we are talking about values that change depending on the equation. And mostly a constant normally has to deal with numbers, and variables has to do with letters and symbols. Alright, so let's look at our example. The first example here, we have 2x, 3x, negative 4x squared, and we are saying they are called terms. They are called terms because 1, a term can be a constant, which is a number. A term can be a variable, which is mostly letters, or it can be a product of a number and a variable, as we have in these two examples. Alright, the next thing I want us to look at is what we refer as like terms. Now, when we talk about like terms in linear equation and inequalities, we are talking about terms whose variables and exponent of variables are exactly the same, but differ only in their numerical coefficients. Alright, what does this one to mean? So, when you look at these examples given to us, we have negative 10a squared, 170a squared, and a squared, and we are saying they are like terms. They are like terms because the variables here are a, and their exponents are all squared, but their numerical coefficients are different. So here we have negative 10, we have 170, and here we have 1. So by definition, all these three terms are called like terms. Like terms because 1, they have the same variables, they have the same exponents, but their numerical coefficients differs. That makes it a like terms. So for example, if I have 4a and 21a, I can call this like terms. Like terms because they have the same variables, but their numerical coefficients are different. Now, one thing you have to note is that we have what we call unlike terms. Unlike terms is the opposite of like terms, meaning that their variables and exponents are not the same. Example, so if I have 4a squared and 2s, let's say 3, this is an unlike term. Unlike term because the variable here is a, and here the variable here is x, and their exponents are not the same. Hence, it is not a like term. Good. The next thing we look at is what we term as a numerical coefficient. Now, when we talk about numerical coefficient, we are talking about product of a number and a variable, the factor which is called the numerical constant of a term. So let's look at the example given to us below. In each of the following expressions, determine the coefficient. Now, per our definition. We said numerical coefficient is the product of a number and a variable, the factor which is a numerical constant of the term. So when we take A, 56B, okay, 56B is made up of a constant and a variable, and we are looking for the numerical coefficient. The numerical coefficient of 56B is the number here, which is 56. When we come to B, negative 5 over 2 A square B square, looking for the numerical coefficient, our numerical coefficient is negative 5 over 2. And I guess you can do the rest. When we take negative 1 over 4xy, our numerical coefficient is negative 1 over 4. And when we come here, our numerical coefficient becomes negative 1.